Hello students, how are you doing? I hope your preparation is going well. So in this session, I am planning to discuss the balancing of chemical equations mainly based on potassium permanganate and potassium dichromate's oxidizing action. Okay, so this portion is in the DNF block elements in your part 1 inorganic chemistry of grade 12. So this is also present as an initial part. The balancing of chemical equations is present in grade 11 redox reactions. Okay, so both grade 11 and grade 12 students may be using this video. So if you missed your lectures, or if you don't remember, or if you don't have any idea about what is oxidation reduction, or what are redox reactions, what is oxidation number, how to balance the equations, if you don't have any idea also, don't worry, I'm going to start from the basics. Okay, so by the end of this video, you will be having a complete idea of the basics which you missed in your 11th standard. So even 11th standard students can watch this video, maybe it might be helpful for them. Okay, so why should I first discuss this topic is this is a sure shot topic. Sure shot topic is every year we are encountering minimum of 2 to 3 marks in the board examination. Okay, grade 12 board examination. There are around 2 to 3 marks in this balancing the equations alone. In the textbook, hardly there are around 7 to 8 balancing the reactions, out of which they are giving you 2 to 3 marks. Okay, so without balancing the chemical equations, we cannot expect a board exam question paper. So I want all my students to secure full marks in balancing the chemical equations. So first, let us go with the basics. In part 1 of this video, I will just talk about the basics of redox reaction, that is what is the meaning of oxidation, what is oxidizing agents and certain things, so that you will have a strong foundation, and that foundation will help you to do the balancing. Okay, so first in your lower classes, that is in your 9th and 10th standard, you might have studied that oxidation is like addition of oxygen. Okay, or there might be removal of hydrogen. So there will be addition of oxygen, which means to any element oxygen may be getting added. Okay, or to any element oxygen may be getting removed. So these are certain basic terminology you must have heard in your lower classes. With respect to balancing, we are concerned only about the electronic changes or electronic transactions happening during a chemical reaction. Like for example, you might have studied this. Okay, so any element, suppose let us take that element A is going to lose 2 electrons. Okay, after losing 2 electrons, it is going to get plus 2 charge, and it will be losing 2 electrons. So in terms of electron transfer, I can say that any element, if it loses electron, then it is said to be oxidized. Okay, you can use this shortcut of LEO. Okay, so LEO means loss of electron means oxidation. Okay, so here this particular element A is losing 2 electrons during this transformation, hence A is said to be oxidized. For example, suppose let me take this zinc. Okay, it is going to lose 2 electrons and it is going to form Zn2 plus, and 2 electrons is lost during this transformation. I can say that zinc is oxidized to Zn2 plus. Okay, a reverse of this is also true. So I said that loss of electron refers to oxidation. Okay, so what if it is gain of electrons? So gain of electron is reduction. Okay, so one example I will just give you. For example, let us have Cu2 plus. Okay, so Cu2 plus is actually having plus 2 charge. What is the meaning of this plus 2 charges? Copper is deficient of 2 electrons. There are 2 electrons less in the copper's outer orbital. So if it gains 2 electrons, so it is going to become copper in its natural state. So here Cu2 plus is undergoing what? It is undergoing reduction. Since it is gaining 2 electrons, I can say that copper 2 plus is undergoing reduction to metallic copper. Okay, so this is our basic idea about oxidation and reduction. Okay, so oxidation means there should be loss of electrons. So an element should lose electrons to be oxidized. If the element is gaining electron, if the ion is gaining electron, then it is said to be reduced. Okay, second, what are oxidizing agents? So oxidizing agents Actually no, they facilitate oxidation. They facilitate facilitate oxidation of other elements. Okay, so let us, the examples or the purview of this oxidizing agent is very very vast, but let us stick to what is actually needed for this chapter. Okay, we have two different oxidizing agents given in our textbook, Indian F-block elements. That is your potassium permanganate, KMnO4. Okay, it's an excellent oxidizing agent. It can oxidize a given element in either acidic medium, or it can also oxidize the element in alkaline medium. Okay, so one is potassium permanganate. When you dissolve it in a respective medium, it will be converting itself to permanganate ion, MnO4 minus. So this is known as permanganate ion. So what is the color of this permanganate ion? You just post it in the comment box. Color. Okay, color. Then another oxidizing agent which is specified in our book is potassium dichromate. Okay, that is K2Cr2O7. Okay, so K2Cr2O7 also acts as an oxidizing agent, but mainly its oxidizing agent action is confined to acidic medium only. That is what is given in our textbook. So alkaline medium also it furnishes oxidizing property, but it's very fissile, or the oxidizing property is very much vibrant in acidic medium. So in acidic medium what happens is it dissociates and it forms dichromate ions, which is Cr2O7 2 minus. Okay, so this is your dichromate ion. Okay, the dichromate ions, you tell what is the color of dichromate ions also in acidic medium. Okay, color. You can refer your NCERT textbook and you can tell me the color of dichromate and permanganate ions. So these are the two oxidizing agents. So basically oxidizing agent will oxidize other elements. We are going to see the examples later. So as of now you need to have an idea about these two elements alone. I mean these two compounds, oxidizing agents alone. One is potassium permanganate, other one is potassium dichromate. Next, what is the oxidation number of this element, of an element? So simply I will just, this is a big topic, I will just simply give you some shortcuts to remember. For example, if you take any element in its elemental state, for example zinc is in metallic state. Okay, zinc is a metal. In its elemental state, zinc will always have an oxidation rate of 0. Okay, suppose copper in its metallic state or solid state, so mostly it will be written as solid state only. You can write like this: zinc in solid state, copper in solid state. Okay, 0. Suppose chlorine, which is in gaseous state, it is 0. So all elements in its elemental state. Okay, in nature how they are available? In nature zinc is available as a solid, copper is available as a solid, chlorine as a gas. Okay, oxygen is acting as a gas, so its oxidation number should be 0. Okay, then we will go back to ions. All the ions, for example Cu2 plus, okay, the oxidation state is +2. The charge is equal to its oxidation state. Zn2 plus, the charge of Zn2 plus is 2 plus, so its oxidation state is +2. Okay, then we have Fe2 plus. What is the oxidation state of Fe2 plus? It should be +2. Then Fe3 plus, so it should be +3. So for all ions, suppose if I have I minus, its oxidation state should be -1. Okay, then if I have Sn2 plus, its oxidation state should be equal to +2. Sn plus 4, its oxidation state should be +4. So oxidation number, how you have to find out is it's like this only. Okay, then some common cases are there. Those common elements we will be discussing. Most of the cases hydrogen will always be having an oxidation state of +1. Okay, for hydrogen the oxidation state is always equal to +1. For oxygen it is always equal to -2. There are some exceptions, but we will not go to those exceptions. For hydrogen it is always +1, for oxygen it is always -2. Okay, so you need to remember this. Suppose if you have any elements like fluorine it is always -1. Okay, so with these examples it's more than sufficient for us to solve all the balancing. This is more than sufficient. If anything else is required, I will just teach you that during balancing the expression. Okay, so two things alone you remember. One, in elemental state, it is 0. Okay, then ionic state, for ionic state, charge is equal to oxidation number. Okay, then some common examples I have given it to you, you can just have an idea about it. Okay, then the next one is how to find out the oxidation number of an element in a compound. Okay, so far we have seen some elements which are, you know, they are all in without forming any compounds. Okay, they are all in ionic state or metallic state. What if it forms a compound? Mainly we'll discuss about these two elements. For example, in Cr2O7 2 minus, what is the oxidation number of chromium? You might have to find it out. So let me teach you how we have to find out. Okay, so there are two chromiums here. Let us take the oxidation state of chromium to be X. Okay, since there are two chromiums, I am taking it as 2X. 2X plus, how many oxygens are there here? 7 oxygens are there. Oxygen always has an oxidation number of -2. Just now I told you, can refer here. So you can see oxygen always has an oxidation number of -2. Okay, so I am just putting it here. So then you look at this entire compound and look at what is the charge. Here we have a charge of -2, so I will just equate it to -2. So if I solve this, I will know what is the oxidation number of chromium. Okay, so 2x minus 14 is equal to -2. 2x is equal to -2 plus 14. So 2x is equal to plus 12, or x is equal to plus 6. So in this compound, chromium has an oxidation state of plus 6. Okay, plus 6. Right. Now let us go back to potassium permanganate. In permanganate ion, that is MnO4 minus. In permanganate ion, let us take the oxidation state of permanganate, manganese, to be X. Okay, X plus. Here there are 4 oxygens and each oxygen has an oxidation state of -2. I will equate it to -1. Since there is -1 charge here, I will equate it to -1. So if I solve X, so X will be equal to +7, which means manganese in this compound is in +7 oxidation state. Okay, I hope you are able to understand the oxidation numbers, how to calculate the oxidation number of an element in a compound. Okay, so mainly we will restrict ourselves to potassium permanganate and dichromate alone, because we are not going to see any other compounds. Okay, so we will just restrict to these two compounds alone, because in DNF block elements we are concerned only about these two compounds. Right, next question. So this I have already solved here. What is the oxidation number of chromium in dichromate ion? Just now I told it is for chromium it will be what, +6. Okay, you can try working out by your own based on what I taught there. Then for manganese in potassium permanganate, it is, just now we have solved, it is equal to +7. Okay, what does it actually mean? What does it actually mean is, see, we know that chromium is a D block element. Okay, so starting from scandium, we have titanium, then vanadium, then chromium. So chromium's electronic configuration will be 3d5 and 4s1. Am I correct? So for chromium, the oxidation, the electronic configuration is 3d5 and 4s1. In +6 oxidation state, you have to remove the 6 electrons. Okay, it means that chromium has lost 6 electrons. So Cr +6, that is in +6 oxidation state, it will be having 3d0 4s0 configuration, which means chromium has no electrons present in the outermost orbitals. Okay, suppose if it is Cr +3. Okay, so I will write it here. If it is Cr +3, so what does it mean? It means that chromium has lost 3 electrons from the outermost orbitals, so it will be having a configuration of 3d3. Okay, otherwise I can write it as T2G3. This is what you might have studied in your D block elements. Why Cr3+ is a good oxidizing agent or good reducing agent? Some question is there in the D block element, you might have studied it, because it forms stable T2G orbitals. What is this T2G orbital? One more time I will just tell you. In crystal field splitting, the D orbitals will split up into 2 different energy levels. So in that, we have a lower energy level called as T2G level. Okay, triply degenerate T2G level, and higher level is called as EG level. So T2G3 means you have D3 configuration. So the electrons get filled up in the lower energy level itself. So this is a stable configuration. Okay, right. Then we'll go for manganese. We know that manganese in its elemental state has a configuration of 3d5 and 4s2. Okay, in plus 7 oxidation state, manganese has lost all the 7 electrons. Okay, in plus 7 means it has lost all the 4 electrons, so it will be 3d0, 4s0. So since there are no electrons, manganese and chromium have a very good tendency to gain electrons. That is why they will be acting as strong oxidizing agents. Okay, so right, so all these explanations I hope you are able to understand. In the next part we will be trying to balance the dichromates in the acidic medium. Okay, so stay tuned. If you like this video, you can just like this video and share it with your friends, and do comment so that I'll be knowing who is watching the video till the end. Okay, thank you. If you have any suggestions, just text to my WhatsApp. I will just make appropriate changes in the video. We'll meet in the next video. Thank you for your patience.